Okay, so I've started the recording earlier before the actual thing. This way we can maybe talk about what we're going to talk about today with some of the people who hopefully will show up. It doesn't have to be, um, uh, of course, if nobody does show up, I'm happy to just go over a lot of the new changes we've been doing in PyHealth, uh, some new setting updates. I got those Discord and this event to the calendar in case you're interested. Um, oh, status. This connection is unstable. Actually, I think we're good. I think we're good. Okay. Yeah, so you can join the Zoom. You can add it to the calendar here. This will add it to your Google Calendar. Um, let's talk about the agenda. We're adding a lot of new memory changes. One of the big things is that PyHealth was not very good at, which was essentially how much memory usage does it have? When using something like Mimic 4, like a very large data set, and trying to do some type of mortality prediction. And so we're doing a lot of different optimizations, and we're adding a streaming mode, which lets you instead of doing the conventional PyTorch data set, now you can do like an iterable data set that can stream samples directly from the disk into memory, and then you can go through patient by patient basically. And so we see a nice almost 10x reduction in memory usage without too much of a performance loss here in terms of just file IO and processing. And so that's kind of nice to see. Like you're getting a lot more value out of these things, and we can finally run it on some much smaller workstations. Although I still can't run it on my own laptop yet. That's might be impossible for given how the current backend works. But it is nice to see that we can do it on substantially smaller machines now. So if you do have 64 gigs of RAM, it should be able to do everything with PyHealth. Other additions, we've been really hard at work. Uh, Really just quickly implementing a lot of new pull requests. We're modernizing a lot of the API to a lot of the new data loading and processing. And so we have a lot of new bounties that were completed. So let's just probably go back to the bounty list. Let's go back to here. Let's see. Recently we had GameNet. This is complete. Contra WR, do we have this on here? Yes. This is in progress. Like we're getting there. We're slowly getting there. This interpretability module has grown quite a bit. We're adding a couple new more methods in here. In this case, we've integrated this gradients, deep lift, transformer interpretability. We're also updating a lot of our docs to include way more examples and how people might use um, uh, these approaches. And so hopefully this is very useful to people who are who are very new to PyHealth and looking at the documentation. Um, it's not great. It's not perfect yet. There are probably some still things that are very confusing, but we have dramatically expanded the docs. Let's see. All right, it's about to be 12. So if nobody shows up, I'm going to probably do a bit of programming just so people can see what it's like to just work on PyHealth. Otherwise, let's give it a couple minutes to see if people show up. Uh, hmm, Heads up. Guess we can announcement that everyone, just a heads up. Hosting schedule chats right now. Let's see if this is still there. And poke some of my lab mates. Uh, Okay, maybe not. We'll see. Um, let's give it a couple minutes. Ignore. I guess while we're at it, we can go over some, as we're waiting, some of the nice new capabilities of PyHealth. Soon to be, I guess we can go back. Ornaments. It's big as this font size. Wait, performance benefits, some code advancements, fiction, CPI. I guess one of the big selling points is lots of documentation. It's not always easy to develop a file. There are like a little bit of like there's a little bit of know-how required in using the software package, but um, and we can go over what we mean by that. But basically, group documentation, um, thematic reduction, code written. Wide variety, extensive, highly integrated uh, medical pipelines, plus diverse tasks. I guess it's modular and diverse set of clinical tasks. Okay, some friends, you don't have to ignore those. Also documentation examples, performance benefits. Um, hey, Yangda, what's up? How's it going?
Hello. Oh, pretty good.
Are you at lunch right now, I'm guessing?
Yeah, lunchtime.
Okay, that's cool. That's cool. Yeah, I'm just working on some figures, so for the paper, I think we're gonna release later. Um, hopefully by the end of January, I think this is on track too. Um, I guess another person's joining. I guess we'll wait for everybody. Hey, Andrea.
Howdy. Sorry, well, actually, no, I was here last week. It was just a bit late. I
Yeah,
don't know.
no
Feels
worries,
like
no
it's been a
worries.
week.
Yeah, it's definitely been a long week for me as well. I've been um I've been working a lot. Like I think last week we were talking about memory issues.
Hmm.
And this idea of streaming or just using like an iterable data set. Uh, and it's actually a pretty like decent solution. Although I can't quite get it below the 32 gigs of RAM mark. So it's like a lot of machines, like my own desktop, it's still like I still can't get it to run on my own desktop, but um we still see like a massive dramatic reduction in memory usage. So it's like uh I
It's still
don't
fantastic.
Yeah, so it's not.
I think it's very good already. I mean, you scale down from 300 to 30, right?
Yeah, without what's cool is like the speed difference is not bad actually. If you just increase the cache file sizes that you're reading and writing from, if that makes any sense, like um, or the amount of rows you're reading, I guess in this case, from a lazy frame. And so yeah, so it's nice to see that like it's not that much slower and it's way easier to run. Let me look at Colab Pro memory limit.
Yeah, I think it only gets slower if you try to random access them.
Okay.
If it's streaming, it should be the identical speed. Uh, as if you load everything in memory. That's the power of streaming because you can always preload. The issue appears when you try to random access it.
Streaming should. Maybe I'm doing this wrong. I'm definitely like vibe coding my way. Like my understanding is basically we have a bunch of things on disk and we just read through it in chunks. But maybe
Yeah,
I miss should
yeah,
randomly
that's a sequential reading. It should be fast.
should be
Like,
fast as normal mode. Um, I guess like is it normal to see like a three sample difference in like speed? I mean, it's not that big, right? It's like so instead of taking maybe like
oh
I don't
yeah,
know,
I mean,
like
if you're using batch size one, then you definitely won't get the speed up, right?
okay.
But I think batch size 1,000 and normal like looks reasonable to me. Like they have a like slight
Okay.
performance penalty, but they should be relatively the same if we read them sequentially.
Okay. I will okay. In that case, I think I'm happy with this because I'm not yeah, I'm not I guess I could do there's another thing I was thinking about, which was like we could definitely save a lot of the processors that I run on the big machine, and that way you don't have to do any extra. Um, so basically, what I realized was if you're building a vocabulary, you need to iteratively update that vocabulary as you're doing in chunks, right?
Yeah.
And so this is a little bit complicated, but not too bad. Actually, surprisingly, most processors don't really like, especially for signals like imaging and these types of data sets, they don't really care about vocabulary updates, but
Yeah, and actually the vocabulary update have some concerns.
mm,
So one is that every time you run them, you get a random order of
yeah,
vocabulary.
yep,
Like even if it's the same data set, because
yeah,
we have some sort of like non-order preserving option, like group by or something that will shuffle the order. Because basically Progress does not give any guarantee for the order for group by unless you specify you want to preserve the order, which then make the player single threaded and very slow.
mm,
Uh, so for example, if I that will create a situation like even given the same data set, if I
yeah,
run the like notebook from start to the end in one pass, it will give the correct result. If I try to load checkpoint,
yeah,
like continue, like resume training, then it will give incorrect result. And also it's a silent error. So
right. It's hard to test for these things, especially within the constraints of the compute limited to the CI.
yeah, I'm thinking if you can just like also save the processor when we save the checkpoint so that like checkpoint and processor should always go together.
Yeah. This has been on my mind. I think this is kind of like a big point. So I think this is good. Oh, whoops. This is no longer the case as I fixed this. But yeah, so this is definitely the do of the update. It's yeah, there's also a couple of quirks with like doing the data set training and test split because you're right, like the it's no longer as nice of a randomized thing. I think we have to like randomize the patient IDs, like randomly split the patient IDs first, and then like have almost like static how do I say this? Like static train test splits, if that makes any sense. Um, Potentially need to also cache train validation test splits for because
Uh,
I think what I understand how this works is like as
is this a split deterministic in the sense that if we fix a C, they always give the same split? Or
my worry is that because this is all very like this is very oh this is the wrong one. This is an iterable data set. I don't entirely understand how it um
or
like if we were to shuffle it efficiently in memory, like this feels like it could be a challenge.
oh
Um
yeah, it's definitely problematic. So the typical way for them is just spin up two iterable data set and skip the one that's not in the
yeah.
uh,
Like so we would have like a training iterable data set and then like a test slash validation iterable data sets.
yeah, and then like it can be just the same data set, but then we put a filter that filter out the patient that's not in this set.
Oh, okay. Could be the same. Yes, filter
Because
bucket.
otherwise, like, because there's a sequential order of iterable data set, right? It's hard to bypass that.
Yeah. That makes sense. Oh, I just see Jyotirshan's here. Hello, Jyotirshan. This is Yongda and Andrea who are, very working very hard and helping us out with PyHealth. Jyotirshan was one of the, I guess, PyHealth mentors over the summer that helped actually publish one of the papers at ML4H. So, um,
Hey John, hey guys.
yeah, I guess for some context, we're just talking about memory wrangling, because this is, yeah, I guess Yongda, if it does only have 34 gigs of like memory, that means you can run it on your machine, right? Your 64 gig.
Yeah,
Okay,
I have double of that size, so
okay.
definitely runnable on my machine.
Okay, hopefully this
Yeah.
actually how much memory do you have on Andrea? I don't know if this is
Mine is in a weird state where it's for some reasons I don't want to get into too many details. It's like 28, I think, right now.
oh, okay.
So that's still going to be a little high. I have a personal to do to upgrade the RAM on my machine anyway, and the computer I just bought over the weekend would technically be able to run it, so that's probably not terrible. Any
Right.
computer worth its salt anymore is, although you do have to pay extra for 64. I'd say given 2 or 3 years down the road, though, 64 is going to start becoming the standard for all laptops and other computers, and I think most desktops should be able to most modern desktops should be able to do that. I'm still a
Yeah.
little concerned from a use case perspective when we're expecting folks to be looking at all of this interpretability. My assumption is that they're going to want some organization to the data because they're going to be looking back through the data sets, and I'm not sure how helpful just looking at random images or random samples in the data set's going to be for that. So that's something we should also consider as we're
Yeah.
going forward. Because if it's always randomizing it, then I think we're going to need to probably add some additional tools to let it be resorted after it gets to that point.
Yeah,
That's maybe
a
coming back to
question
the
for the
interpretability, not so much
interpretability
mimic.
stuff. Sorry, go ahead. Do you want to speak first?
No, you go ahead.
Oh yeah.
Okay.
A question
Okay, go
regarding
ahead.
the interpretability. So do we want to like to get the interpretability of like a single sample, like and get a different like contribution for different sample? Do we want to like somehow aggregate them and say like this factor contributes the prediction label like in general?
I think I think if you can do the individual one, it should be pretty trivial to aggregate the attributions, if that makes sense. Like somebody
Yeah.
else could write that. So the individual case is really key here. I think to Andrea's point, I think that's really it's really about like how do you make it such that you can filter your data set really cleanly and efficiently. Because I think yeah, because I wouldn't be able to tell you what examples do we care about. Like we would need like a clinician, which is fine because we do have a lot of clinician collaborators and people that like we have a couple medical students in the Discord. I think that could be useful in the future. It's just I think I think for our test cases, I think it's okay to do just currently pick the random samples and just build up to it because we don't like let's not overcomplicate it just yet. I think the like we don't want to hard engineer anything if that makes any sense.
Yeah,
Yeah.
no, completely. I think it's once we get the individual random samples, it might be just a case that maybe we add tools that allow you to, because if it's a dictionary, it's pretty easy to organize data, but it really depends on how big your input set is. Because, for example, I know I've still been dabbling a little bit with that COVID set, and it's
Mm.
small enough that just doing like a dictionary read of, okay, let's just get all the samples with label X,
Yeah, yeah, yeah.
and sort it that way is super easy. So I think that's something we can keep in mind relative to as we're starting to get more into like, I mean, if you start talking all of Mimic 4, that's quite a different animal entirely.
Yeah, yeah, I'm happy to yeah, I definitely need to think about like exactly what exactly we want to because there are and it might just be that you just have to pay the upfront cost anyways, so this is like definitely like a moot point. It
Mhm.
could be
Could be, yeah.
or it could be yeah, yeah. But also it could be that like oh, it's too slow and because it still requires 34 gigs of memory, then I only want these samples anyways. Like there probably should be something a little bit more efficient, a little bit easier. And I think but it's quite
Well, it's
a
also
yeah.
well, it's also running like interpretability on the whole data set versus running interpretability on an individual component. Because you're talking about, uh, okay, well, we want metrics that say this particular attribute was the most effective or the most notable. I think that makes sense as far as an output
Mm,
from the interpretability. But that would also require running the interpretability script on everything in the data set too.
right, right, right.
Which
Yeah,
is
it's yeah,
so I
that's
think it goes to a couple different places. It might also depend on the interpretability metric too, because like the visual ones, probably doing individual samples makes more sense. But if we're talking
mm,
about like looking at mimic and saying what's the most important uh code or
yeah.
whatever that's looking at, then that makes more sense to have the entire data set. So anyway, I'm just spitballing, but I think it's 34 is probably in range of good enough for now that maybe it might be worth moving on and coming back at a later point would be my thought.
Yeah.
And maybe it'll give me an excuse to update my RAM. Oh no, server is faster and I don't longer have to close Chrome to
I,
play video games. I mean,
I just want to make a
terrible things.
quick point that I don't know actually I don't know if you can still get Colab Pro, but you should be able to get like 167 gigs of RAM on like a Colab notebook. So that's
Oh, that's juicy. Okay.
yeah, with like a 80 gig. I don't know if you'll ever need that big of a GPU, but it is nice, like a nice to have.
Uh, a quick question for PyHealth. How open are we to external dependencies? I mean, type dependency.
If they're compatible with the existing set of dependencies, I'm good with it. Like I don't think it's we do have, and this is something I've talked to Paul a lot about, which is using Pixie to do like almost like like a dependency tree. Like, oh, I want NLP packages, so I will pip install PyHealth bracket NLP. And those can be like a separate like sub thing. So uh, it depends on like what dependency sometimes too, because sometimes things are very heavy. Like
Yes,
yeah,
technically,
yeah,
yeah.
yeah, yeah.
I'm thinking about the like lightning stuff. There, you know.
Oh, PyTorch Lightning. Yeah, yeah. I think that's a good dependency to have actually, or something that to be
Yeah,
at least make it compatible. Yeah.
it is very heavy, but it can save lots of heavy lifting from
Yeah.
our code.
Yeah.
Like even for like for the dataset one, like it have some like one of their sub package lead data, like have the interpret set that's can cache more like can cache more efficiently, support cloud array, and then like have a better shuffle and subsample than our like implement could. Because I mean, that's a matured package, right?
I'm all for that actually. I think one of the things we wanted to make sure was that it could be compatible with PyTorch Lightning. It's just I guess we don't have any examples for it, so that's that's kind of a problem. Because we most of the demos are just with like the basic baby trainer, right?
Yeah,
And it would be
I
nice to have a
I
lightning
I
example.
think it's just we can like instead of pass a sample data set, we can just pass a data module, which is a Lightning equivalent of
Yeah,
that.
yeah.
And
If
then its trainer should do the job mostly, I guess, unless we need some like special handling, then we can just inherit their trainer.
Yeah, if you want to make I'm happy if you want to make an example if like a data module wrapper, right, around some of these the stuff that we have. I think that should
Yeah,
be like I think that's a good idea actually because I think
it should be relatively simple, and also like their code are personally I feel like pretty
yeah.
economic friendly. So so it should be relatively easy to implement that. I can have a try once I resolve that GM PR comments.
Yeah. Appreciate it. I guess Jeff Thurston, I think do you just use pure PyTorch or do you use also Lightning? I feel like
It's Lightning.
okay. So that's definitely a nice to have to be able to like start reproducing people's work with it.
Mm.
Oh, I guess now that I was on the topic of Joe Thurston here, I think uh I know you wanted to talk about the some of the nice things that have happened recently is we have a lot of signals data sets. So it's like we have heart sound recordings. Um Actually this you know what's interesting, Joe Thurston, is this Razan guy, like Saeed, he's also a BME, so he's like from the same like a very similar biomedical engineering background. So he's doing a lot of these like these signal stuff right now, which is really cool. So like
Right.
and he's like updating, he's adding like audio processors and things like that. And like I think he's helped with the
This can
documentation.
be, yeah, this can be really useful. I recall like our image processor need to pass the like color or something.
Oh, yeah. Like you're talking about this, right? Like this.
Yeah, I'm talking about this, like
Yeah. I
something like
agree.
that. Yeah, I think this is a really useful stuff.
Yeah, I think the schemas feel very heavy, but I think I like the idea of schemas because it makes things really like documented, if that makes any sense. Like it's very much more reproducible than like a typical research repository where I think a lot of people kind of just they'll have it as functional arguments and it's very implicit, but it's not very modular, if that makes any sense. It's very like I've seen there's a lot of research code out there that's just really heavy. So it's nice. Yeah, I have to thank Saeed for doing this. So we have a lot of signals data set, and it's really cool. I think we have sleep EDF in one of the pull requests with contra WR, which is also I guess we can do. He also has like a couple Fourier transform codes here. This is kind of cool. Um, I'm hoping, yeah, just I'm hoping like this should incentivize more of the one of the other threads we had, which was I hope Siddhartha will do it, which is
Confirm.
this idea of negatively sampled conformal prediction for EEG because we do have like an example that works that has a coverage guarantee with I guess for Youngda and Andrea here I don't know how familiar you guys with conformal prediction but the idea is actually pretty cool and it's really straightforward. It just doesn't work in the real world because distribution shifts are always present. You can never assume IID, which is the problem. Uh, but if I zoom in, the cool part is this is really relevant for healthcare, is that your models will classify for maybe like one class usually, right? So on the left here, so in this case, the image classifier is classifying a fox squirrel. But in reality is when your data is really either very noisy or obviously your classifier is imperfect, like maybe you only have a 70% accuracy, it's nice to be able to include prediction sets like almost like a, I guess, confidence interval of discrete variables of the next most likely classes. So if you see something like this where it's like it's definitely could be a fox squirrel, but it could be a bunch of other things, and you want like a human to kind of investigate or check to make sure for a lot of these uncertain cases. Um, it's
Isn't this just standard softmax?
no. So they have but the big difference here is this gives if in the IID setting, it gives you a guarantee that at some alpha value you set, right? So let's say I want this to be 99%, like
Yeah.
the time it'll conclude the ground truth class. So like 99% accuracy of my prediction sets in some sense, if you want to define it like that. You can do that and it'll change how sensitive these prediction sets are with
Oh, I
some,
see.
but of course it assumes the IID setting. And actually one of my first research projects was I was investigating if this could be done with the EEG signals. Turns out like you can't, even though it would be nice to have a seizure detector that has some like guarantee in the hospital setting, because it's really expensive to send a physician all the way down to check on the patient and things like that. Um, and so they do some type of, the idea is quite straightforward. You basically have a calibration set. You get a bunch of softmax scores, right? And of the true class. You have a distribution of softmax scores, and then you just take the quantile that is of that alpha value. So in this case, if you want 95% of the time, you do what is the 95th quantile, and then you have a threshold basically of a softmax score of what to include your prediction sets. Recently, there's a lot of research on like doing this for generative models, and a really interesting idea is instead of taking the true class, you take the softmax scores of all the negative classes, and then you can kind of like go the other direction with the thing. And the idea here is that maybe if your data set's really noisy, it might be um, and it's like a lot of distribution shifts. It might be better to go it from the other direction and just say which ones to not include have a very, very like um, a super sensitive, like very unlikely to, to not include things type of conformal framework. And so uh, this is actually a cool research idea. I think maybe we could bring Rosin in for this and other people in who are interested to basically do this in PyHealth. The cool part is we have a bunch of uncertainty quantification. Actually, probably better to go to the website. I've been updating these documentation. Like we have a bunch of different variants of the conformal framework that we could definitely benchmark our thing off of, and then we can compare. I don't know if Siddhartha has his already on his GitHub. I hope he does. It'd be cool if I could do it because I know he's really busy. 'Cause I know you're really busy at iClear, right?
Yeah.
Yeah. Um,
But are you looking for his conformer hit?
yeah, I don't know if he has any of this.
Maybe you can check his open review manuscript. He might have shared a link to the code
Uh,
anonymous it.
how do I look for how do I see his open review?
Just search for CONF hit. Con hit.
Oh,
So yeah.
this is definitely not double blind anymore.
I mean, since we know Siddhartha's papers,
Yeah. Yeah. I don't know if he has his. Oh, he does have
just search for
supplementary.
anonymous GitHub or GitHub links, anything there on the manuscript. Yeah.
Looks like no, but I think he submitted supplementary material. So, um,
Okay.
okay, yeah, he has his code in here though. He has
All
his.
right. Nice.
Okay. So yeah, we could definitely steal a lot of his things later. Yeah, I just think we need to find the time to like to work on this, or maybe have somebody help us work on this, because it's a really cool idea. And I think, I guess to be fair, in PyHealth, we don't really sell the fact that we have a bunch of the state-of-the-art uncertainty quantification methods, like written by a guy who works now at a quant trading firm, which is kind of funny. So this is Zen. He used to help us, and he's written a bunch of papers on this. But I think it's really relevant, and I think this is definitely on our roadmap. Yeah, PyTorch Lightning. Actually, I should probably write this down. Big subtab. Okay, let's rename this. PyHealth roadmap. Robust model prediction methods in real world healthcare settings. I always think it's interesting, like people like to look at conformal prediction. They always like motivate their papers by saying this could be done in something like a healthcare setting where predictions really matter. But none of their methods work in the healthcare setting. Interpretability module. So this EEG challenge. Consider efficient. Yeah, sorry, what's up, Yangda?
Yeah, in terms of interpretability module, like currently there are a bunch of hooks we need to define, right?
Yes, yeah.
So I think if the module is if like our module are defined in some certain way, for example, if they like use like an like ReLU module instead of using the functional one, then we can
Oh,
stop the module.
right.
But if they just call like f.relu in the forward pass, then it's very hard for us to patch it.
Right. Oh, I see what you mean. I see what you like. One of them is part of the PyTorch mod, like NN module, right? Like the graph.
Yeah, if it's in the graph, we can patch that. Like PyTorch allow us to dynamically swap their module. But if it's like a function call in the forward, then I have no idea how to do that.
Okay.
I mean, there are some tricks to do that, but really complicated.
Yeah, I guess one of the reasons I think it's really important that we it's like we have an interpretability module, not just use some other package, is because we have some level of control over this. It's possible that we just have to make the assumption that not all the models will be compliant with this assumption. And that's probably fine as we slowly expand these things. I don't know. I guess like there is an idea of like I could take a shot at AI replacing all of the F dot really for all 28 model files. I mean, this is like some things we can't control because like Hugging Face models for sure it's gonna be like a huge problem. Because they should we can't control that.
I mean, yeah. There are some ways to patch the f.relu. It's just a bit complicated. Like,
Yeah.
it involve like understand the entire like their tensor graph and then to patch individually. Whereas for other modules, is attribute swap much easier.
Right. Yeah. Okay. It's future concern. I think the good part is for now, like BMS really only cares about StageNet for whatever reason. I guess like
Probably the model they use right now.
yeah, that's the model that I guess that their research team is developing off of. Which is interesting to say the least, because it's just like a variant of an RNN. But yeah, in the future it'd be good to double check this. For the GIM stuff, oh, I forgot to say for GIM, I think I sent a comment about the transformer model. I think the main reason is uh, we do want to support, like just show that we can do attention models for these things. Oh, hey Giovanni, nice to meet you for the first time.
Yeah, it should be relatively easy to adopt it to the transformer module. I mean, the GM itself, the idea is very clear, like three distinct stuff. Just
yeah,
yeah.
I just yeah. Actually, if I think this is just more of like a documentation, like, oh, this is maybe consistent with the paper. Hook standardization is a big problem. I think this could be forward from embeddings, I think is another thing that might need to be standardized in the future. Brainstorming, I guess it's called brainstorming PyHealth like that. Because it's not consistent with all the models. Like a lot of the clinical predictive models will use like some variant of embeddings. But like the API for things like a Hugging Face model or like a ResNet, right? Like these things might be a little bit more complicated. CNNs, EEG models, like EEG embeddings. I guess your Thurston, your model does token embeddings, which is cool, like in a very satisfying way. But like imaging signals, they don't all follow these things. Um, so like, and then yeah, for sure, performance improvements, potentially bringing down 34 gigs of memory to less than 32. This feels very hard, but iterable data set to PyTorch Lightning support. Yeah. Actually, Youngda, I might ask you for a pull request review if that's okay with the streaming stuff.
Yeah, I can take a look.
Okay. I'm happy to I guess I'm happy to yeah get some support on this.
Yeah,
I'm out of my depth.
yeah, I think I also need to do some like experiment to see how that goes. I think there are a couple of more ways to reduce the memory for like for Polaris. It's just need to use the right way to transform them for
Okay.
Polaris to generate the correct plans.
Hmm. Yeah, I think yeah, I'm a complete noob, so actually I can probably just add you as a reviewer now. I think that may be easier since you're very familiar with this. Let's see if I can for the longest time I've Zembong has abandoned me. The other guy who has like a lot of the um who used to work on this extensively. He's graduated, so he's uh no longer cares about me. But uh but he's happy to like give advice. Just confirm digits. 74 proof. Okay. Um let's see. I don't know if I can, is there a way to logic fan, that's right, logic. Let's see the processor, right? I guess triage question mark. I think this right, who actively push to your project. Okay, let's do that. Yeah, I definitely I have probably like the ugliest pull request right now, Youngda. Like I have 20 different files updated and like this needs to be slimmed down a bit. And like some other refactors. Like a lot of this is
It should be fine. I mean, I've seen worse. So.
you've seen okay. Yeah, no, this is like not my favorite PR that I've done. I think there's like some things, yeah. Um yeah. I guess I guess I should ask Giovanni, what's up? How are you doing? I feel like I'm just talking consistently without introducing myself.
Okay. Giovanni, I'm from the UK, so it's enough time.
Okay,
Um,
okay.
it's just about the count. Yeah, nice to meet you. Just been following the Discord actually since August. But I think you posted an announcement and always lurking in the background and seems very interesting. I work with uh, data as well. So I've been working at GSK and there are a few other companies in the data team. And then working now as a consultant, freelance, machine learning, data and bioinformatics. And
Okay, okay.
yeah, and I just wanted to learn more about Homo, about PyHealth, and about and patient data as well.
Yeah, that's really cool. I mean, I'm really happy to like see that people are interested. I guess Yongda, you're also like a machine learning data engineer, right? In some sense.
Yeah. I'm machine learning engineer. Like mainly working on big data stuff, like data mining stuff,
Okay,
with some
nice.
neural network.
Yeah. I guess this is very like. I mean, I guess a lot of people are. I've heard that people are transitioning more into this space. It's just. I guess the word AI has exploded. So, um, no, that's cool. It's cool to see that. I feel like I don't really know how to do anything other than write papers, so it's nice to see people with a lot of experience who are really interested in this stuff. Um, I guess you were the one who suggested about the federated learning stuff, right? Like Flower AI. I think that was the um
So I mean, I never used it, but I was looking at it for other reasons. The testimonial seems positive. The people seem
mm,
to be happy, and I think there's a guy who uses it just to parallelize jobs. So you have a lot of smaller machines, old machines,
mm.
and this guy trains the data using federated learning, not because of privacy in that case, but just because it's convenient.
Okay.
And but it will be, I think it will be quite a change in terms of code because the, the syntax is similar to normal PyTorch, but
Hmm.
yeah, it's I think I need to modify some stuff.
Yeah, I think I mean this is quite like it's a very different how do I say this? From what I understand, there's a lot more networking involved. Like you need to make sure you're managing a bunch of devices and then somehow it like all comes together. Although it does seem like I don't know. There are some questions in my head because there's how do I say this? I guess like academic institutions are very like it's very difficult in for academics to like just from personal experience to be able to get access to patient data in the first place and then being able to like connect an endpoint that like points to something else. And remarkably, it feels like it's easier for industry to do this because they can just like pay enough money or come up with some business deal, you know, like where like if you're a professor and you're a faculty member and you want to do like healthcare AI research, maybe for with maybe more like a scientific or maybe altruistic purpose. It's weirdly harder for you, and this is like a common sentiment. Like if any of you guys will, I mean, hopefully next year we can get more papers in ML4H and we can sponsor people to like fly over there. Like that would be really cool for this community. But basically, every time you talk to researchers there, there's like this jaded opinion where it's like, okay, maybe I should just go to work for like Google Health because Google Health has billions of dollars and can just, like go to the hospital and just straight up like brute force their way in. Whereas like if you're just a faculty member, you gotta like connect to the hospital, you gotta convince that like 90-year-old old director physician guy that at the top of the chain that like stamp like give you the stamp so you can work with this private patient data. And the moment you do, like here at UAUC, one of the projects we work on it's stuck on the Nightingale server. Like we have this thing where like everything is in this giant private server if you're working with private patient data. And it's like it's not bad, right? Like you have lots of memory, like 500 gigs of RAM. It's, you've got a couple A100s in there. But the problem is it's not connected to the internet. And so anytime you want to install a package or do anything, you have to do like some weird like proxy thing that only goes through their system. Um, and not to mention, if you ever want to use Hugging Face, it's a pain because you have to manually download the model file to your current machine, then do some type of secure copy all the way to this machine. And it's like very painful, I guess. It's like a super painful experience. And not to mention like the programming interface is just like you no longer can use AI programming tools, which is I think good for some people because some people don't need it, but I think I haven't really written real code by hand in a long time. So I'm definitely like it becomes kind of yeah, so everything kind of slows down a little bit. And it would be cool if there was like a nice infrastructure where you could like where you wouldn't need all of this. Like you can throw something very lightweight in there, and then you can kind of aggregate gradients to maybe whatever model that you do care about. But that's yeah, yeah.
It's not just for healthcare. Like almost all field of AI have this issue there. Like you can only get toy
Mm,
example, toy data set from
mm.
like public accessible place, and a company typically hold much larger data, which means they can train a much better model.
Yeah, that's actually a fair point. I remember at Amazon when I was working there, like public data set, public. There's this Amazon reviews public data set, right? That every other company and every other lab may or may not do research or just train on, right? Um, that was scraped from, I think that was scraped by like UC San Diego or something. And at Amazon, all the Amazon research teams were legally not allowed to touch this public data set, even though it is of scraped from their own site for whatever reason. And the reason being was Amazon has like a legal thing with like customer data where they're not allowed to like you need permission, and it was just wasn't available. So
Oh yeah,
even
there's a bunch of like stuff like I think EU have like GDPR,
oh
and then like uh, California has like consumer protection stuff.
yeah
And basically, like as an employee, you have like certain restricted access to data. I mean, for a normal person, if they break the law, no one cares. But for Amazon, if they find out one of their employee like illegally access some data, then big fine for them.
Hmm.
Uh,
Yeah.
yeah, it's the same thing when I work as an MLE in our company. That
Hmm.
like, for example, I typically cannot access EU data just because how EU law say it.
That's
Yeah,
it's not yeah,
like
yeah.
I can train so I can train a model on EU data, but then I
Oh,
cannot
okay.
directly observe the EU data. I can only like develop a model based on
Oh,
US or
okay.
Canada data. And then because it's the same format, right? You
Right,
can just
right.
move that code to the EU server and make it run. But you can only hope that model perform will be as good as the data on like US,
That's
right?
actually kind of funny. Yeah.
Yeah, you don't know the results. So
Yeah, that's actually really funny to think about. I think I think in healthcare we have like a uh I guess like the Mimic series of data sets is like the only thing people use because it's very it's the thing that you can actually observe and do research on.
yeah.
And so um but I will say one of the things I've noticed just because of how like research code is written, people rarely break out of the mold of something like a lot of the works that exist out there purely focus on like things that are very simple to do, like mortality prediction. Um, so if you look at like I'm going to call out our own lab for doing this. Like if you look at something uh, like graph care, for example, and you look at their paper. So a lot of like these types of papers were, so in this case, it's about like building personalized knowledge graph for patients, and then you construct this knowledge graph, and then you can enhance a lot of the performance on these downstream clinical predictive tasks, which is like a pretty cool paper. But if you look at the tasks that people commonly do in the healthcare setting, because of like how little and how I guess like how poor quality a lot of these healthcare tasks are processed, just even using within the same data set series, it's like you'll always see mortality prediction, you'll always see readmission prediction, you'll always see length of stay prediction, and you always see drug recommendation. Um, and there's very little like oh, how would this work for a specific disease, right? Like how would this work for diabetes prediction, right? Something a little bit more concrete. Because so we have a physician in our lab. His name is, it's kind of funny. His name is, if this ever loads, Hanian. So it's kind of cool. There's like a full-time physician who's also a PhD student in our lab, and he's like some director at Mayo Clinic or something. And if you ask him, like does any of these clinical tasks like provide any utility in understanding, diagnosis in these large data scenarios or length of stay? Like, does this actually help you as a physician? And it's like very rarely yes. Like it's very some things might be important, like if you have an ICU patient who comes out and you want to predict whether or not you want to let them go. So something like readmission prediction is useful for that. But things like drug recommendation, where it's like maybe you just don't trust it, or mortality prediction, which is like, okay, I know my patient is gonna die soon or something, but like from what exactly is very hard to answer. And also, physicians often obviously already have some idea of what their patient conditions are, right? I mean, they're working with the patient, so it's like, um, suppose the patient had diabetes, it's a more useful question to ask, okay, like what exactly is leading up to these conditions, or uh, things like that are more targeted, I guess, that you can answer questions. And I always felt like because of how hard it is to work with these data sets, and this is something I hope PyHealth can do more of in the future, is with like the task API and these things, just making it easier to explore um, actually, I don't know if I have this and like something like this. Let's go to DPA, CKD. Just making it easier to do like things like survival analysis of like chronic kidney disease, like explore a lot more disease conditions from these healthcare data sets, uh, to ask more relevant clinical questions. Um, and there are a lot of like things out there. Like we have a collaborator. His name is Dr. Adam Cross. So I guess if any of you guys are really interested in, and maybe I did invite a bunch of people here to meet with the professor. I think he's going to ask some of you guys if you're interested in working more with a physician on these things. Um, but basically, we're collaborating with like a pediatrics clinician at like a hospital system. I think in Chicago as well as Peoria or something, to actually work on building more models for specific conditions. Um, and so, yeah, one of the things I always felt was like, okay, you have all these AI researchers, they all do the same task, and they're definitely overfitting to some of these tasks. So to some point of it's kind of questionable if these new performance improvements are really useful. Um, I think one of the more recent ones I think is like using LLMs. I think where's this one? This one points to a bunch of papers that are constantly using mortality prediction with large language models, which like the idea of LLMs in healthcare is interesting because it provides kind of like an interactive interface, but it's not really necessarily clear if this is not maybe not the paper. Let's see, reasoning enhanced, this one. And there's like a bunch of related works. If you look at the related work section, there's a bunch of these people trying to do LLMs for, and then they'll benchmark on like again, the same mortality prediction
I
readmission.
think like reproducibility is even worse, right? Company can just change model secretly, and then like if you're just using API, you have no idea to know that.
Yes. Yeah. Although they do provide versions, like they'll have a version ID in some of the APIs, which is nice. It's the problem is like the research community also only really cares about the latest version of the model so a lot of the times because nobody wants to explore all the different variants. Um, so yeah, reproducibility is a big problem because the newest version is always changing. There's always some tuning that's happening. And people are always trying to like claim something about like healthcare. Hey Naveen.
Hey John, yeah, sorry, I had a conflict, so just trying to catch up.
No worries. Let me know if you have any questions. We're just going through, I guess we're having a casual chat talk about problems with the healthcare research landscape.
Yes.
Yeah. I will say, I guess this is a good way to end this. I think I don't know if
I think there's a question in the chat.
Oh,
you want
more
to-
question. Why and what are we creating out of specific AI applications in healthcare? Yeah, that's a lot
Trying
of
to sum it
the,
up.
yeah, sorry, go ahead.
Just trying to sort of sum up the core of what you're talking about as far as the commentaries about them overfitting and a lot of people working on a lot of the same applications with a lot of the same models doing some of the same things.
Yeah. I think
I'm not sure
the
if you have an answer to that.
I think the reasoning is like okay, so there's like a cost of entry to entering this space, right? Especially with clinical things. You need some bit of domain knowledge. It's a lot easier to, as like a scientist or a research scientist, to understand what mortality prediction is, right? You just somebody dies or not, right? It's a lot harder to like, oh, this person has stage 4 chronic kidney disease. What is the difference between that and stage 3, stage 2, and stage 1? Why do we care? How do you justify it? How do you find a reviewer for this, right? Like if you're trying to publish this, so like if the computer science department is very focused on getting publications and grants from effectively like at CS conferences, right? And so the reviewer, the average and not to mention the mess that is these CS conferences in terms of reviewing, but also like, you know, so if you want to make really rapid progress on some like new method idea that you're trying to sell to the healthcare AI application, it's a lot easier to start with something one that's already kind of justified in the literature in the sense as like an ML problem. Like people, it's a lot easier to cite a bunch of papers that say that they all do this, like all these 10 papers do mortality prediction, than it is to say, okay, now we're doing diabetes for some reason, right? And then you have to find baselines and you have to write this thing. Um, Even though if you ask a clinician like to bridge the gap and you talk to someone like Dr. Cross, it's like, okay, what do I actually care about? It might be something like tracheitis or something, or like maybe, predicting pneumonia, right? How likely given that they're, what are the patient directory, what type of conditions have they seen in the past? What is the likelihood of we need to put them on antibiotics? Like these types of things could be more relevant, but they're also a lot more sparse. So there's a data sparsity problem, and then also just generally there's like very little code to do these things, and making an interface that can do this type of processing very like modular wise is I guess that's like one of the goals of PyHealth, like doing something that you can so once you create an ML task, okay, now we can go straight into like, okay, now I want to do interpretability, right? Because physicians really care about this, or like pharmaceutical companies really care about interpretability, to understand what their model is looking at. And so there's like these things that you want to make it connected, but they're all very disjoint things. Like the researchers working on interpretability for healthcare are probably very disjoint from maybe from the people who are doing mortality prediction or doing, in this case, like, LLM based things. And it's all very like, it's like a very sparse thing. And it's not clear how one goes about standardizing this, but I am really happy people are interested in PyHealth because I think like this would be a step forward in trying to make it easier to answer more important clinical questions. Even if the data is just mimic for repeatedly. Yeah, sorry, go ahead, Andrea.
No, I was gonna say, no, I think that sums it up actually, and I think that makes a really good use case for where PyHealth could be valuable. One thing I would probably ask is that as we're going forward with adding some of these various interpretability models, that we ask the question of what is a good use case for what it could be used for, and start maybe adding some of those examples, just as that might be easier for people to see where the value comes in.
Yeah, I think
That's a statement of physicians, because I mean I talk
right.
to my husband regularly, and he's a physician as well, and he'll and some of the things that come
Yeah,
up of
yeah.
like, okay, like mortality prediction in his line of work isn't going to be helpful at all. So okay, so
Yeah. No, exactly. I think so we are using mortality predictions as a very easy thing to do right now. It's like off the shelf for in fact, in some sense, you're really
it's
only
popular.
interpreting. Yeah, it's popular. It's very. It's actually one class. You don't have to do a multi-class thing.
Well, it's still binary too.
Yeah,
Well,
yeah,
not
yeah,
binary, but it's more simplified,
yeah.
my impression of a lot of AI tools in the past, and maybe where AI finally got popular is it got out of the is it a hot dog or is it not a hot dog mindset.
Yeah,
And
cat
once it
versus
got,
dog. Yeah,
yeah,
yeah.
exactly. So,
I,
but maybe I'm rambling a little bit, but I just want to make sure we're sort of asking why are we putting this together and what the purpose is, and just keep that in mind as we go forward.
I think this would be a good idea. I think I'm definitely gonna probably reach out to Dr. Cross. Just he has a DKA project that we actually, funnily enough, Vipin, one of our I guess PhD student collaborators, is doing something with like DKA prediction with StageNet, which is kind of funny too. So everything is kind of
That's handy.
just very centralized on one model, so you can make it very transferable. I might ask him to send him over to actually merge his task that he built here. So that way we can do something like oh, this is not well documented. Um, but basically that way we can do something that's actually very clinically relevant. Um, there is another benchmark that Stanford came out with, EHR shot. And this is a big deal because actually for the longest time, a lot of these clinical predictive modeling tasks were very focused on ICU patients. And so if you want like general domain, so a lot of physicians complain is, okay, you train your model on mimic. How do I know if it works on the general domain? And we do have like a rough thing for this, but we can do things like, prediction of hypertension. So these are pretty like some of the very relevant conditions in these tasks. Um, and I can definitely train a model for that. I think for each one of these, I think that should be pretty straightforward to do actually. And then we can just apply our interpretability techniques across a variety of different conditions.
Ooh, that'd be really good thorough testing, and really clear examples too of like, oh, you can use it to say how well it performs on this and that and the other
Yeah.
thing.
Right.
See,
Yeah.
hyperkalemia, hypoglycemia, hyponatremia. Yeah, those are some.
Yeah. If
If
your
they're
husband
words I
wants
if
to.
they're words I was gonna say if they're words I recognize, they're pretty common then.
Okay. Yeah. If your husband wants to take a look at this and give us some advice, I'm happy to like we the paper is not set in stone on mortality prediction. I think like it's just what we're starting off with, but
Mm-hmm. I gotta start
obviously,
somewhere, right?
yeah, right. Yes, yeah. Obviously, if interpretability is a lot more meaningful when it is of a like an important medical condition. So, um, uh,
Well, as I said, just full transparency too. He's a psychiatrist, so his angle is going to be very different than just your standard conditions because he's definitely
hmm,
more concerned about mental conditions than medical conditions. Although those do come up quite a lot.
I believe depression is an ICD code. Like there are a lot of things like schizophrenia, like these things. There are, and so this could be like something we do, potentially. It just depends. Um,
Yep. Okay, all different angles is good to look at.
yeah, I agree. Um, I think the good part is, from what I've noticed, is it's very easy to take like one of these tasks that already exist and just like have an agent generate a new task. It's kind of, I don't know, it is kind of cool. Like you just have to give them some examples like, okay, look for these ICD codes, this specific one, and then that's your label, right? That's the diagnosis condition. And then you can kind of create samples and sets of patients of these things. The danger is some conditions are really sparse and really rare. So yeah, we have to you I think less than 1,000 samples and then your deep learning model is really questionable.
Yeah. Well, I mean, as he keeps telling me, what he wants is not necessarily something that tells him it's a zebra, but tells something that reminds him that it could be a zebra.
Mm,
So it's maybe not necessarily as important that a model calls out, hey, it's this rare condition with reasonable confidence. Just as going back to that commentary about making or having a prediction set of, hey, could be these things. And then it could be on the doctor at that point to go and say, okay, well, I know it could be these things. And hey, I didn't even remember this random thing existed. Let me go look that up. Because you hear a lot of stories about people with zebra conditions. They're diagnosed as the common condition because they share symptoms.
yep.
And
Yeah.
then
Yeah.
the clinicians that they were talking to didn't even know until they found like the Uber specialist that actually has seen that condition before. They never get a diagnosis. So
Yeah, I think this is it's a good point. I just think this is this part is really hard because we need to like Jitharshan, who was here earlier, I guess Siddhartha is also involved. Basically, it's really hard in research to do it on like if you notice a lot of the prediction set papers, actually, if you do ever happen to read a couple of those, they're very afraid to use like there's never going to be a healthcare data set. Like even Zen has like very I don't know. Let's look at one of his papers for maybe FavMac. I don't know if this is um, the healthcare scenarios. Although he does like something like here, um, they're not. They're either very clean or they do a very like yeah like they'll do like mimic with some select few of labels, and it's very difficult um, to like maintain certain conditions of like, hey, this is like I can give you a 95% guarantee that one of these conditions is the ground truth. And so like they'll do um actually I don't know, he'd like MNIST like some of these easier like baby data sets that are really nice to work with. What do you do with Mimic? We
good proof of concept, not necessarily helpful as far as so if you have a model that just calls out the bread and butter horse condition or the condition every physician is going to think of the first time they look at someone, that's not exactly going to be helpful.
yeah, I think it's all like, in my opinion, one big pipeline because the reasoning is you would probably ideally want something like this where like it gives you some coverage guarantee. He might have diabetes, he might have hypertension, he might have all these conditions. Maybe it's a multi-label process too, and then you have some guarantee in a multi-label predictor. And then the physician will be like, why, right? Like I think so then that's when the interpretability comes in. Okay, here's what it's looking at specifically. Does this make sense? Do I trust this prediction? Maybe I should overwrite the model. Um, I think for image classifiers, I guess that's a bigger one, right? For X-rays, like is it looking at the correct X-ray parts of the X-ray, or is it looking in the corner? You know,
Yeah.
like
Oh, I've seen that a lot when I was doing the saliency mapping with the
yeah,
COVID
yeah,
database. It's like, hey, is it looking at the bones of the shoulder, or is it looking at the actual lungs, or is it staring at the heart, or did it notice that there was a center line and it pointed that
right,
out? Like,
right,
and
right,
if there's a center line, like, yeah, they're probably really sick. So I mean, okay, that's that.
right.
But maybe that's not the most helpful thing for determining like, do they have pneumonia or something?
Yeah, I think and also the other issue is like your interpretability approach could be complete nonsense too, right? And this is something that we really want to investigate for clinical predictive models, which is just like, okay, it gives you an explanation. First of all, does it make sense with given this black box model that you don't really entirely understand? And two, if it if it does conform, does it make any human sense at all? I think that's like there's like two questions to that. Um, because a lot of the times like you how do I say this? I think there's this the research community really likes image like really simple image data sets, like transform image. And then they'll sell some like so here the visualization is very straightforward. It's like a dog and a cat. It's like something that everybody can understand. But for something like healthcare, it's like a way more complicated question. So like um anyways, yeah. All this to say is I think what we're building here is actually like really cool. I think it all could work together in the future, and I think that's a very exciting idea, to me at least. It is 1:10. I know you guys are all on lunch and you should probably get back to work, so I don't want to like keep this going.
Thank you.
Yeah. Thanks for coming, everyone. I'm really happy to just chat for an hour every day. Yeah.
Bye.
All right. Yep, take care, everybody. Yep. Bye.
Okay.